Good morning, friends and my dear children. This is your Lalita ma'am is again back with another topic, a new topic which I am going to start from today onwards. The topic is nomenclature of organic compounds. In today's topic, I am going to just give only an introduction. Okay, so on the request of so many children, I am going to start this new chapter. Okay, request all the students not to relax as exams were postponed and for some children exams were cancelled also. So request all of you not to relax. Okay, keep learning. Okay, keep watching the videos, and kindly those who are watching the videos for the first time and visiting the channel for the first time, kindly go through the previous videos and subscribe to my channel. This is Lalita Peri, a science teacher, and basically I teach chemistry. Okay, so let us move on to the today's topic, that is introduction to organic chemistry. Okay, so I'll just give an introduction to organic chemistry. Introduction to organic chemistry. Okay, now I think if I write so top, you cannot able to see. I'll just write it a little bit down. Sorry for the disturbance. Okay, introduction to organic chemistry. Introduction to organic chemistry. Organic chemistry, really a very big world. Okay, there is much to learn in this organic chemistry. I think you all are aware that chemistry has been classified into three parts, that is physical chemistry, inorganic chemistry, and organic chemistry. Okay, so in this topic we are going to learn about organic chemistry. Okay, so let us have a discussion of what is organic chemistry. The word organic chemistry stands with the chemistry of carbon compounds. Okay, organic chemistry is the topic which deals with the chemistry of what? Carbon compounds. Okay, now the chemistry of carbon compounds, you call it as organic chemistry. Organic compounds mainly consist of what? Carbon. Okay, now the chemistry of carbon compounds, you call it as organic chemistry. Okay, what is organic compound? Organic compound. Organic compound means the compound which consists of three elements, mainly three elements. What are those three elements? The compound which consists of mainly three elements. What are those three elements? Mainly carbon, oxygen, and hydrogen. These three elements should be there. Okay, now if any compound consists of mainly carbon, hydrogen, and oxygen, then such kind of compounds they are said to be as what? Organic compounds. Okay, and the whole chapter deals with carbon and its compounds. There are many compounds. Carbon is the only element which can form millions and millions of compounds. So that's why we have to learn about the uniqueness of carbon also. So in this video, I am going to deal up to the unique properties exhibited by carbon. Okay, only certain unique properties that are being exhibited by carbon, that only up to there only I am going to discuss in this video. The video is going to become a little bit lengthy also. Okay, but without skipping the video, if you can able to follow what all the topics which we are going to learn, okay, then definitely it will be very much useful for all of you. Okay, now because it's a big world, I request all the students to kindly write and practice. Okay, so organic compounds are the compounds which consist of mainly oxygen, carbon, and hydrogen. The main element for the main base for organic chemistry is carbon only. Okay, so previously scientists were in a view that organic compounds cannot be synthesized in the laboratories. Okay, now we cannot prepare organic compounds in the laboratories. Scientists were in that view. That means organic compounds can be prepared only means inside the body of living organisms. Okay, there will be certain vital force will be there. Okay, and organic compounds can be synthesized only in the living organisms, and they cannot be prepared in the laboratories. Artificially, we cannot prepare organic compounds in the laboratories. Okay, that was the thought was there when Berzelius found that there will be some vital force is there, some vital force. Okay, some vital force is required to prepare. Okay, now is required to synthesize, better I say, synthesize. What is the word synthesize means? The word synthesize stands for preparing. Okay, now for the synthesis, making, vital force is required for the synthesis of carbon compounds. Okay, that means we cannot prepare them in the laboratories. Scientists were in that view. Scientists were in a view that organic compounds cannot be prepared, okay, now cannot be synthesized in the laboratories. Okay, Berzelius told that some vital force is required for preparation of organic compounds in the laboratories. Okay, so generally organic compounds means the compounds which consist of what we call certain carbon and along with that oxygen compounds, okay, which are generally produced inside the human bodies or inside the living organisms. Okay, like you might be studying starch and glucose, all these are prepared, okay, inside the human body after digestion. That means for that a vital force is required, and that theory you call it as vital force theory. Berzelius is the name of the scientist who told about this. Berzelius, okay, told about what? Vital force theory. Okay, but this vital force theory was rejected. Okay, after Holler, for the first time he prepared organic compounds in the laboratories. Okay, now Holler, scientist named Holler. Okay, name of the scientist is what? Holler prepared organic compounds for the first time in the laboratories. Holler. Okay, so that's why Holler is honored with the father of organic chemistry. Holler is the name of the scientist. Prepared organic compounds for the first time in the laboratory. Okay, now prepared organic compounds for the first time in the laboratories. Okay, for the first time he prepared organic compound in laboratories by heating what? By heating ammonium cyanate. Okay, ammonium cyanate is an inorganic compound. Okay, ammonium cyanate. Okay, ammonium cyanate is an inorganic compound. Okay, ammonium cyanate. Ammonium cyanate. The formula is what? NH4CNO. NH4CNO is the name of an inorganic compound. So Holler just started heating this ammonium cyanate, okay, and accidentally forgot that he started heating that and accidentally left it like that and went away. Okay, so he actually forgot that he started heating this inorganic substance. So that inorganic substance keeps on heating and heating. Okay, when it keeps on heating, this has been converted into another new substance on heating continuously. Okay, on heating continuously, this has transformed into another new substance, okay, with the same molecular formula. Again he observed with same molecular formula, NH4CNO means two nitrogens are there, NH4 Look at the formula carefully. 2 nitrogens. Here also 2 nitrogens. Okay, now 4 hydrogens. Here also 4 hydrogens. And 1 carbon. 1 carbon. 1 oxygen. Here also 1 oxygen. The same ammonium cyanate has been transformed into urea. This has been named as what? Urea. Okay, now ammonium cyanate has been transformed into what? Urea. Okay, so for the first time he prepared an organic compound. Okay, an organic compound by heating an inorganic substance. Okay, in the laboratory. Accidentally he prepared. Okay, and later acetic acid was prepared. Okay, ethanoic acid was prepared. So many things so many organic compounds by the discovery of Höhler, they thought that organic compounds can be prepared in the laboratories also. Okay, previous to this, scientists were in a view that organic compounds cannot be synthesized in the laboratories. Okay, some vital force is required to prepare them inside the living organisms only. Artificially, we cannot prepare them in the laboratories. They were in that view. Okay, but by the discovery of urea, okay, now by the discovery of urea, okay, Höhler for the first time prepared organic compounds in the laboratories. Okay, that's why he was honored as what? Father of organic chemistry. Okay, now Höhler was called as what? He was honored as father of organic chemistry. Father of organic chemistry. Okay, now Höhler. Right? So this was the introduction for what? Organic compounds. Okay. So I said the whole organic compounds consist of what? Carbon. Carbon is the main element. Okay, now carbon is the main element for what? For all organic compounds. So carbon is really a very special element. Okay, now. So what are the unique properties of carbon? That we have to learn for today. Okay, the video will be a little bit bigger. Okay, so please hold on. Okay, for unique properties of carbon. What are the unique? Carbon is so unique. Okay, you all know about carbon. So carbon exhibits certain unique properties. What are those unique properties? Okay, now, so that we have to learn for today. So mainly carbon exhibits certain unique properties like catenation, isomerism, okay, allotropy, formation of multiple bonds, okay, and tetravalency. These are the unique characteristics exhibited by only element carbon. No other elements are exhibiting such unique properties. That's why carbon is considered to be very special. Okay. Main base of organic chemistry is what? Which element? Carbon. You all know carbon atomic number is 6. Okay. Atomic mass Z is 6. Atomic mass or mass number means what? A. It is 12. AMU. AMU means what? Atomic mass units. Okay, AMU, and its electronic configuration is what? 1s2, 2s2, 2p2. Okay, valence electrons are 4, so valency is equal to 4. Valency is equal to 4. That's why it is considered to be what? 4th A group element. Carbon is considered to be 4th A group element. These points which we already know, right? Now we are going to learn about the unique properties of carbon. What are the unique properties? If the video length is going to be become more, I'll just stop by explaining two unique properties in this video and the remaining properties in the next video. Okay, we'll see. Right. Okay, unique properties of carbon. Very, very important. What are the unique properties of carbon? Okay, so what are the unique? Unique means what? Different from others. Okay, carbon is very special, I was telling you. Okay, it is completely different element. It is the only element which can form millions and millions of compounds. So what are the, let me introduce the unique properties of carbon. So what are the unique properties? First one is allotropy. Second one is catenation. Okay, and third one is isomerism. Okay, formation of multiple bonds. Okay, and tetravalency. Okay, tetravalency, that is also there. Okay, tetravalency exhibited by carbon. Okay, these are the unique properties. Means what? Special properties of carbon. That's why, because of these unique properties only, carbon can able to form millions and millions of compounds. Okay, so let us learn these unique properties. Okay, so first one is what? Allotropy. What is allotropy? First one is allotropy. Okay, so what is meant by allotropy? Allotropy is defined as existence of same elements in two or more different forms. Okay, same element but exists in different forms. Allotropy means what? Existence of same element in different forms. Okay, you call that as what? Allotropy. Existence of same element in different forms. Okay, so what are the different forms? Even you people also, like being children, with your father you will behave in one way, with your mother you will behave in one way. Same child but behaves in different ways with different persons. With one teacher you will behave in one way, with another teacher you will behave in another way. Isn't it or not? Same person, same child, but different behaviors, isn't it? So in the same way, carbon also. Okay, also exhibits the property of what? Allotropy. Same carbon but exists in different forms. Okay, so what are those allotropic forms of carbon? Okay, so if you speak about the allotropic forms of carbon, this topic of allotropy itself will take a little bit time. So I'll just explain only about allotropy, up to allotropy in this video, and then the remaining properties we'll learn in the next video, right? So what are the different allotropic forms? So mainly allotropic forms are classified into two types. Okay, allotropes of carbon have been classified into two types. What are those two types of allotropic forms? First one is crystalline allotropic forms and amorphous allotropic forms. Okay, two types. Okay, now allotropes of carbon has been mainly divided into two types, crystalline and amorphous. So what are crystalline? Crystalline means having 3D structures. Okay, if all the elements of any substance has been arranged in a particular order, okay, with the regular arrangement, okay, like 3D structures, then you call that as what? Crystalline structures. Okay, means all the elements are arranged in a regular order. All the elements are arranged in a particular pattern. Okay, in a particular pattern. You call it as what? Crystalline, 3D structures. Amorphous means no regular arrangement, powdery forms. Okay, very brittle. Okay, powdered, they are very brittle. If you are going to hold them, you can break them easily with your hands also. Okay, such fragile substances. Okay, amorphous allotropic forms. So what are those? No regular arrangement. Okay, now powdery structures. Okay, now powdery fragile structures. Okay, powdery fragile structures, amorphous. Okay, of course I am not saying that they are not hard, they are also hard only, but still, okay, they are not so hard as that of crystalline forms. Okay, so let us learn certain examples for amorphous allotropic forms and then crystalline allotropic forms. Okay, so examples for amorphous forms, let us learn. Examples for amorphous allotropic forms. Amorphous allotropic forms of carbon. Okay, what are the examples for amorphous allotropic forms of carbon? So first and best example is peat. Just we will learn the names of certain allotropes of carbon here. Okay, peat. Peat is an allotropic form. Lignite. Peat, lignite. Bituminous coal. Bituminous coal. You might have learnt. Bituminous coal. Okay. Anthracite. And one more thing is what? Anthracite. Okay, that means based on the percentage of coal, based on the percentage of carbon, okay, present in the particular substances, okay, certain allotropic forms have been decided. Peat consists of less amount of carbon, only 60% of carbon is present in that, and in olden days they used to use this peat as for lighting of objects, as a fuel. Okay, as a fuel. Same like that, 60 to 70% of carbon is present in lignite. And bituminous coal, you might have studied about this in class 8. Okay, allotrope, one of the allotropic forms, best fuel. Okay, bituminous coal. Okay, like in what we call fractional distillation of coal, in that you might have come across these words. Okay, bituminous coal. Okay, this is the one which is used for surfacing of roads. Okay, now for road making, for making of tar, damper roads. Okay, bituminous coal is one of the allotropic forms of carbon that is being used. And next is what? Anthracite. Anthracite is the oldest coal. Maximum percentage of carbon is present in that. Okay, now maximum amount of carbon. Okay, oldest coal. Okay, and can be used as a very good fuel, you can say the best fuel. Rich source of carbon is present in that. Okay, anthracite. So these are what? Allotropes of amorphous allotropic forms of carbon. Okay, same like that, examples for crystalline allotropic forms. Crystalline allotropes. Crystalline allotropes of carbon. So what are those? Diamond. Second one is graphite. Okay, and you might have heard about graphene. Graphene is also one of the allotropes of carbon. Graphene. Okay, and nanotubes. Okay, in class 10 you might have come across these kind of crystalline allotropes of carbon. Okay, now crystalline allotropic forms of carbon. Diamond. Okay, now diamond, you all have studied. I said crystalline forms means they have regular arrangement, a particular pattern will be there. Okay, so you might have studied in class 10. Okay, here diamond, if you speak about, all the elements present in that particular substances are what? Carbons only. All the elements are carbons only, but they are arranged in a regular pattern. What is this? Ma'am is drawing rangoli. You are thinking like that. No, See here. Okay, the dots which I kept, all those are what? Carbons. All these are carbon atoms only. Middle also carbon, up also carbon. Everywhere, everything is carbon only. Okay, so all of the carbon atoms which are present in diamond have been arranged in a regular pattern. Okay, in a regular pattern. See, all the carbon atoms, same element, but different forms. Carbon only can exist in the form of peat, can exist in the form of diamond, can exist in the form of graphite. Okay, same element, but exist in different forms. That is what you call it as allotropy. Okay, so carbon, all carbons only, but with regular arrangement, 3D arrangement, 3-dimensional structure. So this is what? Diamond. Okay, diamond. Okay, and the characteristics of diamond and all you might have studied. Okay, I'm not going to deal with all those things because that will become a very big concepts. You can just go through the concepts, like it is undergoing what? 1, 2, 3 sp2 hybridization. Okay, tetrahedral structure, isn't it? Tetrahedral structure is there. Okay, so like that hybridization structures, bond angles and all you will be studying there, right, later. And if you go for graphite, this is what I said, diamond. Regular arrangement is there. Graphite. If you go for graphite, graphite will have hexagonal ring structures. Okay, like this, hexagonal ring structures. All the carbon atoms are arranged in regular patterns here also. Okay, in the form of what? Hexagonal rings. Okay, joined together like this. Okay, hexagonal ring structures. All the dots which I am highlighting are what? Carbons only. Okay, like this, in the form of layers. Okay, like in the form of layers. Carbons, all carbons are arranged in the form of layers like this. Okay, here one layer and again here one more layer. So this graphite will be looking like this. Okay, in the form of different layers. Bond angles and all I just told you, no, here I am not going to deal with it. I am just introducing what is allotropy. That's it. Okay, so like this, in the form of different layers. Okay, layers. In different layers, all the carbon atoms have been arranged. Okay, so such kind of arrangement you call it as what? Hexagonal ring structures. Hexagonal ring structures. Okay, hexagonal ring structures. And you have one more important thing is there. C60 is there. C60, one of the allotropic forms of carbon. This is what you call it as Buckminster fullerene. Buckminster fullerene. Okay, Buckminster fullerene. This is third allotropic form of crystalline allotropic forms of carbon. Okay, now third one. What is that? Buckminster fullerene. So Buckminster fullerene will be like a buckyball structure. Buckyball. Okay, now what is buckyball? Like a football structure, which consists of what? Hexagonal and pentagonal ring structures. Okay, now hexagonal and pentagonal ring structures will be there. Okay, so buckyball structures. Okay, some will be pentagonal structures. Okay, some will be hexagonal structures. Okay, like football structure. On football you will be finding certain pentagonal rings and hexagonal rings. Okay, so on the surface of a football. Same like that, the C60, Buckminster fullerene. Okay, Buckminster fullerene. That means all the points, intersection points are what? Carbon atoms only. Okay, arranged in a regular pattern. Okay, and in this also, it consists of totally 32 rings will be there. Okay, now 32 rings will be there. Okay, in that 20 hexagonal rings are there and 12 pentagonal rings are there. 12 pentagonal rings. Okay. So total 32 rings are there, arranged with 60 carbon atoms. Okay. So it looks like what? Buckminster fullerene looks like a buckyball or like a football. Actually, the word came from a famous architect, okay, who has constructed a building in, I think it is there in America. Buckminster Fuller is the name of the architect who has constructed geodesic dome. Okay, you can search. Okay, geodesic dome. He constructed a building. Okay, in America it is there. Okay, so this football like structure, the building construction is like a football like structure. Okay, you can see in the picture, right? Geodesic dome. Okay, a big football like structure. The whole building looks like a football like structure. Okay, and that you call it as what? Geodesic dome. Okay, and Buckminster Fuller has constructed that building. Okay, and now as this allotropic form of carbon is resembling to that structure, okay, that was named after as Buckminster fullerene. But this was discovered by H.W. Croto and R.E. Smalley. These are the names of the scientists. H.W. Croto and R.E. Smalley. Okay, these two are scientists who discovered Buckminster fullerene. Okay, I think this is not visible. H.W. Croto. H.W. Croto and R.E. Smalley. Okay, now R.E. Smalley. These are the names of the scientists who has discovered this Buckminster fullerene, and that is resembling the building which is being constructed by a famous architect named Buckminster Fuller. So Buckminster Fuller is nowhere related to chemistry. He is an architect. Okay. Scientists are these. H.W. Croto and R.E. Smalley discovered that Buckminster fullerene. Okay. But he named them on the name of the famous architect, Buckminster Fuller. Okay. Geodesic dome he constructed. So it consists of all 60 carbon atoms in the form of 20 hexagonal rings and 12 pentagonal rings. Okay, and this is used as a biomolecule, you know. This is used as a biomolecule for the treatment of cancer. Okay, melanoma cells which are there in our body, cancer causing cells, okay, can be, this is injected in the form of a biomolecule into the patient's body and can be used as a cure for what? Cancer cells. Okay, so that is the importance of this C60, Buckminster fullerene. Okay, and then graphene. Graphene is one of the layers of graphite. We have learned, I just now told you that graphite is present in the form of what? Layers. Okay, different layers of graphite are present. Carbon atoms are in the form of different layers. Okay, graphene is one of the layers of graphite. Okay, folded three-dimensionally. Okay, it looks like a big rocky substance, but it's a very lightweight substance, very unique substance, graphene. Really, it looks like a big, what we call a big rocky substance, but such a lightweight substance, it can be mounted even on a flower also. Okay, such a lightweight substance, and it is very strongest allotropic form also. Okay, strongest. Graphene is 200 times stronger than a steel wire. Okay, graphene 200 times stronger than a steel wire. Okay, now stronger than a steel wire. Okay, such a strongest allotropic form, graphene. And the last one is what? Nanotubes. Nanotubes are also like copper wires. Okay, best conductors of electricity. Okay, that's why they are used as an alternative nowadays. Okay, nanotubes are being used as an alternatives, okay, for copper wires also. Generally copper wires are used for wiring, you all know. Okay, nanotubes, nowadays we are using these new technology. Okay, nanotubes is also one of the layers of graphite has been folded together. Okay, you can see in the pictures, right? So these are the different allotropic forms of carbon, crystalline allotropic forms. Okay, so only the property of allotropy has been discussed in this video. Okay, so by seeing the pictures, please go through the pictures and all, and write and practice. Request all of you to kindly pause the video, keep writing the notes. Okay, make the notes, okay, regularly, and follow your own notes so that your memory power will increase. Okay, so I'm going to stop the video up to here, right? The remaining allotropic forms, unique properties exhibited by carbon, that we are going to learn in the next video. Okay, only allotropy I have discussed here, right? So thanks for watching, dear children. Okay, keep learning, do not waste your time, do not relax. Okay, learning the topic slowly definitely will make you perfect. Okay, your hard work is your superpower. Thanks for watching. Bye.